Today we're going to talk about dividing polynomials. So the first type of dividing we're going to talk about is when we divide a polynomial by a monomial. So when we divide a polynomial by a monomial, we're going to end up dividing each term of the polynomial by the monomial. So we're actually going to skip down to example 1. And so right now I have a polynomial as my numerator and a monomial as my denominator. So what I'm going to do is take each value of my numerator and divide it by my denominator. And then I'm going to simplify anything that's simplifiable. So my first one, I have t squared on top and a t on the bottom. So that will simplify to t over 8. In my middle term, these t's will divide to 1. And then 6 over 8 will reduce to 3/4. In the last term, t will stay in the denominator, but 16 and 8 reduce to a 2 in the numerator. So that is how we divide polynomials by a monomial. So go ahead and pause the video now and try examples 2 and 3. So if you check examples 2 and 3, this is what you should have gotten. Notice I'm simplifying any numbers that can be simplified as well as any variables. So now let's go back up and look at these problems I put at the top of the notes. This should look familiar and should probably flash you back to about 4th grade when you learned how to do long division. So today we're going to be doing long division of polynomials. So before we do that, we're going to do some long division back like what you did in 3rd or 4th grade. So the first thing when we do long division is I have to look at this 44 and think about how many times 44, well, it goes into 9. We know that's 0. And then how many times 44 goes into 94, which will be 2. Now I do 2 times 44. And that's going to give me 88. And so I'm going to subtract that from the 94, and I'm going to get 6. Now I bring down that next term, so I have 66. Now I look at 44, and I think about how many times that goes into 66, which is 1 time. 1 times 44 is 44, so I'm going to subtract 44. And I'll be left with 22, and then I'm going to bring down that last 0. Now I need to think about how many times 44 goes into 220, which is going to be 5 times, because 44 times 5 is 220. And then I'm going to have 0 remainder. So my final answer for this one would be 215. Go ahead and pause the video and give the other 2 long division problems a try. Play the video when you are done. So when you did long division on the second example, you should have gotten 173. And when you did long division on the third example, you should have gotten 111. So keep in mind this process that you used for these types of problems, because we're going to use them when we do long division of polynomials. So when we do division, there's many ways we can write it. So a lot of times the original problem will be written such as it is number 4, where it's a polynomial divided by a polynomial divided by a binomial. So I could always rewrite this division problem in a different way, such as a fraction. And we've seen these with the examples that we did yesterday. Now, it's great to rewrite it like this if the top polynomial is now factorable, which in this case it is. The top will factor into x plus 2, x plus 5, and it's going to be over x plus 2. Since it's factorable, now I can divide x plus 2 divided by x plus 2, and so my final answer will be x plus 5. Now this only works if the numerator is factorable. If the numerator is not factorable, then we have to do long division. So on the back of your notes, example 6 is an example of long division. So this polynomial, t squared minus 5t plus 10, is not factorable. So I'm not going to be able to write it like I did on the front. So I'm going to use long division. So I'm going to write my binomial on the outside of my division, and I'm going to write my polynomial on the inside of my division. So now I'm going to use the technique that I used in the long division problems at the top in order to solve this long division problem. So I'm going to look at my t on the outside and think, okay, t times what is going to give me t squared? Well, t times t gives me t squared. Now I'm going to take this red t and multiply it by my blue numbers on the outside. So t times t is t squared. T times 3 is 3t. Now, just like with the long division, I'm going to now subtract. So t squared minus t squared is 0. Negative 5t minus 3t is negative 8t. And then I'm going to bring down this positive 10. Now I'm going to do the same thing that I did to start with. I'm going to look at this t, and I'm going to say t times what will give me negative 8t? Well, t times negative 8 will give me negative 8t. Now I'm going to multiply negative 8 times t plus 3, and I'll get negative 8t minus 24. And just like I did last time, I'm now going to subtract. Negative 8t minus negative 8t is 0. 10 minus negative 24 is going to be 34. So now 34 is my remainder because I cannot multiply t by any whole number or whole variable in order to get 34. So when you have a remainder, you are going to write that as a fraction. So my remainder is 34 over t plus 3. All right, let's do another example like this. So if we look at number 7, the top is not factorable, so I need to do long division. So I'm going to have 4b minus 3 on the outside and 20b cubed minus 27b squared plus 13b minus 3 on the inside. So now I'm going to think about 4b times what is going to give me 20b cubed? Well, 5b squared. Now I multiply 5b squared times 4b minus 3, and I'll get 20b cubed minus 15b squared. And now I'm going to subtract, and I will get negative 12b squared, and then I'm going to bring down my next term. Now I'm going to look at this 4b and say 4b times what gives me negative 12b squared? Will be negative 3b. So I'm going to multiply that negative 3b again times 4b minus 3. So I'm going to get negative 12b squared plus 9b. And I'm going to subtract those, and I will end up with 4b. And then I'm going to bring down my last term, which is minus 3. Now, 4b times what gives me 4b? Well, that's just a 1. And 1 times 4b minus 3 is 4b minus 3. So in this case, I have a remainder of 0. So my final answer would be 5b squared minus 3b plus 1. Go ahead and pause the video now and try example 8. When you're ready, play the video. Go ahead and check your answer for example 8. In example 8, you did get a remainder. So remember, when you get a remainder, my remainder was 2. I wrote it as 2 over 2d plus 3, which was my divisor. The last thing we're going to look at is when we have polynomials with missing terms. So what does that mean? So it means that there is a gap between some of our terms. So if we look at this first one, I have an x cubed and I have an x. What I don't have is an x squared. All the examples we did above were in standard form and had all of the parts of the polynomial. So in this case, I want to rewrite this as x cubed plus 0x squared plus x minus 2. Because when I'm doing long division, I need to have that placeholder in, so I don't accidentally skip a spot. So when I go to do long division for this problem, I need to make sure that I put a 0x squared into that part of the polynomial that's missing. So now when I do a long division, I'll think about x times what is x cubed, which would be x squared. Subtract, and you'll get x squared. Bring down the x. X times what is x squared? Well, x times x is x squared. So I'm going to have x squared minus x, which will give me 2x. Bring down the negative 2. X times 2 would give me 2x. And in this case, I have a remainder of 0 again. So my final answer would be x squared plus x plus 2. Go ahead and give example either 10 or 11 a try. When you're ready, play the video. I will do both, so that way you can check depending on which one you did. So in example 10, you were missing your x term. So when you write out the long division, you want to put in a 0x in between your x squared and your 1. When you did number 10, there was no remainder, so your final answer was 2x squared minus 3x plus 3. In example 11, you were missing your y squared term, so you need to put a 0y squared in. And when you do that, you will get a remainder of negative 3. So remember, when you get a remainder, you write it as the negative 3 remainder over the 3y plus 2.